Hi everyone. Okay, in the previous lecture series, we already covered on analyzing force vector in two-dimensional perspective. For example, if you have the x-axis over here and this is your y-axis and your vector happens to be in between the x and the y-axis, you can actually resolve this vector or split this vector into two components, which is the x direction and also the y direction. Okay, so right now we are going to focus on the more realistic aspect of vector analysis, which involves this additional thing, a 3D perspective. We have an x, a y, and also a z. So we'll see how to do that. Okay, stay tuned. A 3D vector problem would involve three axes this time around. So instead of dealing with only x and y, now you are dealing with x, y, and also z direction. So you can easily visualize the direction of the positive xyz axis using the right hand coordinate system. So this is my right hand. Take out the first three fingers, the thumb, the jari telunjuk, and also the middle finger. Now you kepakkan all your three fingers so that it would be about 90 degrees to one another, like this. Okay, so the thumb would be the positive x direction. The jari telunjuk, the pointer finger, would be the positive y direction, and the middle finger would be the positive z direction. So if I were to illustrate it like this, if I were to shift it like this, so this is my x, this is my y, this is my z. If I want my z to be on top here, so pusingkan jari tu, so this is my x, y, and also z. Okay? Okay. The question now is, how do we visualize a vector which crosses all three directions, as in it crosses all x, y, z direction? Okay, to illustrate that vector, let me draw a big giant cuboid. Okay, big giant square cuboid so that it's easier for you to illustrate the concept of 3D vector. Okay, my big box is done. So now let's draw the xyz axis based on the right hand coordinate system. If this is my x, this would be my y, this direction would be my z axis. The vector A would be from the origin of the 3D axis up to this particular point. Let's call this vector as A vector. In 3D perspective, the A vector can be resolved into the x direction, y direction, and also the z direction. The A vector along the x direction would look like this, and we are going to call it AX vector. Okay, the A vector along the y direction would look like this, and we call it AY vector. And the A vector along the z direction will look like this, and let's call it the AZ vector. So notice that all component vector, as in AX, AY, AZ, is bounded by the box. Okay, it doesn't exceed the box that we draw. It is bounded by the box. So, complying to the vector addition principle, we can say that vector A is equivalent to vector AX plus vector AY plus with vector AZ. In the Cartesian form, we can rewrite vector A as AX in the direction of I plus AY in the direction of J plus AZ in the direction of K. Using the similar trigonometric equation, we can calculate the magnitude of A by using the formula of magnitude AX squared plus magnitude AY squared plus the magnitude of AZ squared, and then you have to square root all the summation value. Similar with the 2D model, we also need to identify the direction of vector A along the x, y, and z axis. In order to illustrate the direction of vector A in three-dimensional perspective, I'm going to redraw three similar vector A's. Okay, nice. Sekarang ni, if we want to measure the direction of vector A, we have to measure it across the respective axis. For example, along the x-axis, direction of vector A would be alpha, like this. So along the y-axis, the direction of vector A would be beta, like this. And along the z-axis, the direction of vector A would be gamma, like this. Now, very carefully, we draw a line connecting vector A and also vector AX. Okay, so this angle would be 90 degree because dia cuboid kan, dia macam box. So if we project this triangle into two-dimensional view, this is how it's going to look like. Okay, the magnitude of AX would be over here and the magnitude of A would be over here. Okay, so if you notice, it's a 90 degree triangle. So your alpha would be over here. So you can use the trigonometric relationship to calculate cos alpha to be equivalent to the sebelahan next to it, which is AX, divided with the length of the hypotenuse, which is A. And if we rearrange this equation, we can find the magnitude of AX to be A cos alpha. Now let's repeat the same process for the y direction. You draw a line connecting vector A and vector AY, and then we know this would be 90 degree. If we project this triangle into two-dimensional view, this is how our triangle would look like. Okay, the length over here would be AY, and the magnitude of the length over here would be A, and our beta would be over here. Again, similarly, we can use the trigonometric relationship whereby cos beta is equivalent to next to it, which is AY divided with the hypotenuse, which is A. We rearrange the equation and we can calculate the magnitude of AY to be A cos beta. Sama je kan? Okay, repeat the same process for the z direction. We draw a line connecting vector AZ and also vector A. This angle would be 90 degree. We redraw it in two-dimensional view and our triangle would look something like this. Okay, the length over here would be magnitude AZ and the length over here would be magnitude A. The gamma angle would be over here. So again, you can use the cos relationship. Cos gamma is equivalent to AZ divided with magnitude of A. And if we rearrange the equation, we can calculate the magnitude of AZ using the relationship of A cos gamma. Now, let us look at this example. In this example, given the vector f which crosses across x, y, and z axis, the magnitude of f is given to be 200 Newton. The question asks you to show the vector f in Cartesian vector. Okay, every time you nampak je perkataan Cartesian vector, terus dalam kepala you imagine the IJK punya format. Okay, lah ni saya redraw balik the image in the box form so that it's easier for me to illustrate the alpha, beta, gamma punya angle. Okay, using the formula I gave to you earlier, we can actually calculate the magnitude of fx by using the formula f cos alpha. Okay, so our f in this case is 200 Newton and alpha is unknown. Okay, so we just leave it as it is. We can also calculate the magnitude of fy using the formula f cos beta, and our beta in this case would be 60 degrees. So substitute the f to be 200 Newton and cos 60. Use your calculator and you will get a value of 100 Newton. So the magnitude of f along the y direction is 100 Newton. Okay, accordingly, you can calculate the magnitude of vector f along the z direction using the relationship of f cos gamma. And the gamma in this case is 45 degrees. Okay, so our f is known, which is 200 Newton, cos 45 degree. Use your calculator and you will get a value of 141.4213 Newton. Okay, the next step is we can use the formula of f magnitude to calculate our alpha angle, which is the only thing that is unknown. Okay, so remember the formula to calculate the magnitude of f is equivalent to magnitude of fx squared plus fy squared plus magnitude of fz squared, and then square root all the equation. So all the fx, fy and fz value are calculated earlier. You just substitute the values in the equation, whereby fx is equivalent to 200 cos alpha, and then jangan lupa letak bracket and put square, plus with the fy is 100 Newton, letak bracket, put a square over there, and plus with 141.4213, and then you letak square. So all the summation you kena square root it. Okay, now we know that the magnitude of F is already given, which is 200 Newton. So, you put the 200 Newton over here. Okay, now saya nak hilangkan square root on the right side. So, in order to do that, I have to power 2 for both sides, the left and the right side like this. Okay, the 200 become kuasa 2 and then the square root dah hilang, and what's left is 200 cos alpha squared plus 100 squared plus 141.4213 squared. Okay, rearrange the equation, bawa 200 cos alpha squared ke kiri and the remaining expression on the right side. Okay, so saya kira siap-siap, the value is 10,000.0159. Okay, so now nak hilangkan kuasa 2 dekat sebelah kiri tu, I have to square root the 10,000 magnitude over here. Okay. Okay, I think the step lepas ni dah jadi mudah. You boleh buat sendiri and you will get a corresponding value for alpha angle to be 60 degrees. Okay, dah habis dah ke? Not yet. Remember, the question asks you to represent the vector f in Cartesian vector. So, you have to put it in the IJK format. So, vector f would be equivalent to magnitude of fx along the I direction plus with magnitude of fy along the j direction and plus with the magnitude of fz along the k direction. Sekarang ni, semua value ni dah ada, dah complete. So, you just substitute it into your equation. So, fx is 200 cos alpha. Alpha tadi dah kira, which is 60 degree. And then plus with the fy, which is 100j. Plus with the fz is 141.423. Okay. So, you complete the equation. And this is your final Cartesian form. Dah siap. Okay, now let us try to do the second example. In this example, shown in the figure over here, the Spider-Man is shooting its web at 2 different directions. So, you need to calculate what is the resultant force's magnitude and also what is the direction angle. So, kalau tengok sini, if you look at the Cartesian vector, dia ada IJK, meaning it is a 3-dimensional kind of problem. Okay, let me quickly redraw the two force vector of the spider web, which is force vector A and also force vector B. Okay, so we know kalau kita nak calculate the resultant vector, let me call it R, kita kena tambah vector A with vector B. Okay, so we can rewrite the Cartesian form of vector A, which is 60j plus 80k, and then we rewrite the Cartesian form of vector B, which is 50i minus 100j plus 100k. Now, bila kita nak solve the Cartesian vector equation, kita kena solve ikut direction dia. So, first kita tengok dekat I. I cuma ada 50i sahaja. So, you put 50i. And then for the j direction, there are 60j and there are also negative 100j. So, 60 minus 100 in the direction of j. And then along the k direction, ada magnitude 80 and then plus with 100. So that is the value along the direction k. Okay, you sum up the magnitude according to its respective direction and you will get a vector equation of 50i minus 40j plus 180k. Okay, lah ni soalan minta the magnitude of the resultant vector. So you can calculate the magnitude of resultant vector using the equation of Rx kuasa 2 which is 50 square plus with the magnitude of Ry which is negative 40 and then kuasa 2 kan dia plus with the magnitude of Rz which is 180 kuasa 2 kan dia and then square root all that equation. Okay, pakai calculator je and you will get a corresponding value of 191.04. And what is the unit? Oh, the unit is not given in the question. So let's just assume the unit for this vector is in Newton. And vector B is also in Newton. So the corresponding magnitude for resultant vector is 191.0497 Newton. Okay, for the second question, dia tanya the direction of the resultant vector. So you have to know what is the alpha, the beta and the gamma of the resultant vector along the x, y and also the z axis. Lah ni kita tahu from our resultant Cartesian vector, this 50 would be our Rx, this negative 40 would be the magnitude of Ry and this 180 would be the magnitude of our Rz. We can use this information to calculate the direction angle. Using the trigonometric relationship, we know we can calculate Rx equivalent to R cos alpha. So Rx, we already know which is 50. The magnitude of R, we calculated earlier, which is 191.0497 cos alpha. So tinggal satu variable sahaja. So you can easily calculate the alpha angle using this relationship. So, using your calculator, you will get the angle alpha to be 74.8283 degrees. Okay, you can use the same formula to calculate for the angle beta. Cuma this time around, you pakai formula Ry equivalent to R cos beta. So, Ry is known, which is negative 40, and your R is already known, already calculated earlier, which is 191.0497. So, you can calculate your beta simply from that equation. Use your calculator and you will get the beta angle to be 102.0854 degree. Okay, done for beta. So, to calculate the gamma angle, you can use the same step whereby you define what is the magnitude of Rz to be R cos gamma. So, substitute all the values that you calculated earlier and you will get the gamma angle. Simple je kan? Dah siap. Okay, if I were to illustrate the position of the resultant vector, probably it will look something like this. Okay, from the Cartesian vector, we know that the magnitude of the vector along x direction or the Rx value is 50, positive 50. So this is how it looks like. Okay, the magnitude of the R vector along the y-axis is negative 40. So it must be on the negative side of the y-axis like this. It's not on the positive side, it's on the negative side, ke kiri. And then we know the magnitude along the z direction is 180. So kalau 180 positive, it goes upward. Okay? Okay, kita pun dah calculate the alpha, beta, gamma angle. The alpha angle is the angle along the x-axis, which is this side. So this is 74.8 degree. And then the beta angle is the angle of the vector along the y-axis. So this is our beta angle. And the value yang kita kira tadi is 102.09 degrees. And then respectively, the gamma angle is the angle along the z-axis. So kita dah kira tadi, the angle is 19.58 degrees. So this is the direction of the R vector.